The New South Wales Resources Regulator provides safety information to mine operators in the New South Wales mining industry to help achieve safe mining operations. To comply with mining regulations, mine operators must develop and implement principal control plans, including a mechanical engineering control plan. When incidents such as an unintended release of mechanical energy occur, mine operators must review and revise control measures at their mine sites. We have reviewed control measures associated with 2 lateral load shifting incidents that occurred in 2019. Since 2015, 81 incidents have occurred in the New South Wales mining industry involving lifting, towing and snigging. 37 of these incidents resulted in workers being injured. We have published information on our website about these 2 lateral load shifting incidents. The first was an investigation information release titled "Worker Injured Releasing Jam Conveyor Chain," and the second was a safety alert titled "Flight Bar Ejects Hitting Worker While Installing a Conveyor Chain." Both of these are available to download from our website at www.resourcesregulator.nsw.gov.au. The armoured face conveyor, known as the AFC, had a flight bar jammed in the bottom race on an earlier shift. It was possible the chain or a flight bar had been damaged while freeing the chain. The workers had tried to use the pivot arm tensioners to slow run the AFC, but the tailgate pivot arm tensioner was not operational. It was determined the main gate drive pivot arm tensioner would be operated in reverse, and the shearer would assist by pulling the slack AFC chain from the main gate drive. Workers were tasked with inspecting the AFC chain for damage. The inspection required running the AFC chain in reverse. The towing assembly used consisted of recovery strops, synthetic rope, bow shackle, and a rud link. Shortly after the load was applied to the towing assembly by tramming the shearer, the rud link failed. The bow shackle and rope recoiled back towards the 3 workers at the main gate. The bow shackle hit the shearer operator on the lower right leg. This diagram shows the lateral load transfer system that the workers set up. 2 50-ton Kevlar tow strops were used. A strop connected each strand of the AFC chain to the tow rope. A single 42mm synthetic rope was connected between the tow strops to a large bow shackle. A bow shackle connected the rope to the shearer. The shackle had a working load limit of 35 tonnes. The attachment point on the shearer was an 8-ton rud link. The workers did not know the tractive effort of the shearer. It was capable of a maximum traffic effort of about 56 tonnes. The tractive effort of the shearer could have been reduced by disengaging one of the 2 drive motors. A safe working procedure did not exist for this task. The previous shift had conducted a JSA, but this was not used. The workers did not review the JSA nor conduct their own JSA. The workers had not completed the required training. 3 workers were in the vicinity of the main gate ramp pans to inspect the AFC chain as it moved around the main gate drive. The shearer operator was in the roof support walkway, about 22 metres or 15 roof supports from the failed connection point on the shearer. Because the rud link failed on the shearer, the release of energy caused the rope and the large shackle to recoil towards the workers. 2 other workers were also at risk of being hit. This diagram shows the rated capacity and the braking load for each component in the lateral load system used. When the braking load of the components are compared, the weakest component in the system was the rud link with a braking load of 32 tonnes. The shearer was capable of exerting up to 56 tonnes of pull force, therefore exceeding the strength of the rud link. Independent metallurgical analysis identified the rud link fractured across 2 opposite corners. There was no fatigue or pre-existing cracks on either fractured surface. The deformation of the rud link indicated a sideways and twisting loading of the link was not in accordance with its intended use. Our investigation information release provides information about the incident and how to safely use a rud link. The shearer original equipment manufacturer has also published a technical bulletin on the use of lugs and links fitted to the shearer. Although the braking load has been discussed, the working load limit is the primary rating used to select components for lifting and snigging applications. The conveyor chain had broken on a continuous miner and was being reinstalled. An LHD and QDS winch were being used to pull the chain back onto the miner. As the chain came around the foot shaft sprocket, a flight bar jammed. One side of the flight bar failed and was ejected, striking a worker in the shoulder. Other workers nearby were also placed at risk. This diagram shows the lateral load transfer system the workers set up. A QDS winch on an LHD was connected to the chain by a 22mm synthetic winch rope. The capacity for the winch was about 10 tonnes. The 22mm synthetic winch rope had a yield capacity of 42 tonnes. A 3-tonne rated sling was looped around each side of the flight bar and threaded through the eyelet of the rope. The load on the system at the time of failure was not known, as the conveyor chain jammed. One side of the flight bar failed and recoiled towards the spotter, who was on the platform. The workers did not have a safe work procedure for the task. The manufacturer's manuals did not provide specific information about where or how to connect the rope, nor details of how to pull the conveyor chain onto the miner. No-go zones were not specified. A worker was on the platform of the continuous miner acting as a spotter. A second worker was adjacent to the boom of the continuous miner, acting as a spotter. A third worker was standing beside the winch. A fourth worker was in the LHD operating the wind. The worker standing on the platform of the continuous miner was hit in the shoulder by the flight bar when it failed. The other workers were also at risk if the load transfer system had failed in a different way. Before the incident, the 22mm synthetic rope had failed. The rope was repaired and the task continued. The initial failure was not reviewed nor assessed, and the workers did not put additional risk control measures in place. This diagram shows the braking load for each component in the lateral load transfer system. The winch was hydraulically set up to apply a 10-tonne load. The braking strength of the flight bar was unknown, but was not expected to fail. For a task set up in this manner, the LHD should never be driven, as the maximum tractive effort of the machine becomes the load. In reviewing both of these incidents, similar causal factors were identified. There was no safe work procedure existing for either task. The weakest components were not identified because the braking loads of each of the components were not understood. There were problems with training and competency of workers, and supervisors were not present during both tasks. In review of both case studies, there were similar causal factors identified. Connection point strength was less than the load used for the task. The weakest links were the connection points selected. Incorrect no-go zones were identified. And earlier events before each incident of equipment failures had not been reported and reviewed by supervisors. Our recommendations: develop safe work procedures for lateral load tasks. Dynamic lateral shifts are complex tasks. The New South Wales Resource Regulator recommends the following. Mine operators should review their lifting and towing equipment management plans to ensure all activities using lifting and towing equipment are appropriately addressed, including non-routine towing activities. Mine operators must provide adequate information, training and instruction to protect workers from risk while carrying out lifting and towing tasks. Mine operators should seek the appropriate engineering advice in the design and selection of equipment when conducting complex lifting and towing tasks. If the ratings and strengths of any components are unknown, stop, seek advice. When planning a task involving lifting or towing, the rating and yield load of all components, including the connection points, must be considered in the design of the lifting or towing system. Additionally, the structure supporting the connecting point should also be considered. People designing towing, pulling or snigging activities must know and understand the maximum forces capable of being applied to the system, such as tractive effort or weight force. Safe standing zones must be established to account for component failures within the system. Mine operators should review compliance reporting systems to ensure workers notify a supervisor when pulling and lifting failures occur. Workers should not resume the pulling or lifting task until supervisors are notified of the failure and the incident is reviewed with additional controls put in place.